Okay, in this example, this demo, I'm just going to show you some manual segmentation. So here I've loaded an MR scan into the MITK workbench. I'm using MITK. I'm relatively familiar with it. I don't have any particular preference. Other tools like Slicer will provide similar things, and a typical radiological workstation will also have similar tools. So in this case I'm going to segment, let's create a new segmentation, let's call it blocked sinuses. And typically, if we look up here, this is the thing I'm going to segment, this blob here. Depending on what you're doing, there'll be a natural view. So here I'm going to just mainly focus on the axial ones. I'm going to start at the top. I'm selecting a tool. Here it's a contouring tool, so I just draw around the thing I'm interested in, and then I move on to the next slice. This is quite a typical thing. In clinical practice, most workstations, I guess, or most outlining, it's still called contouring because that's what people are doing. At least it's slow, but it can be done very accurately and reliably. So here I'm just going through, just for a bit of variety. For example, I could use some painting tools. So instead of contouring per se, I'm colouring in these pixels here. Let's do another slice like this. And then I'll switch back to contouring. Won't take too much longer now. I know most people will say, oh, you can do everything with deep learning, which is true, but you still need somebody to go through and produce training data, which, unless you've got an automated algorithm, still involves manual contouring. Now, I will be able to show you some other tools like thresholding or region growing, but we'll do that in a minute. So let's say that's the thing I'm interested in. If I switch back to the 4-quadrant view, hopefully now we can see I have here a blob defined. It's shown here in red. If I look here over on the left, you can see I've got two images. One of them, if I make the block sinuses invisible, you can see I've got an image, which is the MR image. If I make the MR invisible and just look at the block sinuses, this is a 3D scan with a very small number of pixels labeled. Question now would be, how do I convert that into a triangle mesh? So in MITK, I right-click and it has down here create polygon model. So let's do that. And what it has done, it has run the marching cubes and it has converted those bits of image data into a triangle model. So let's try zooming in here. I'll turn off the crosshairs. So what is this blob exactly? Let's zoom all the way in. So this is not voxels or pixels, it's made up of triangles. We can see this surface representation. If I switch to wireframe, you will see that this is defined as a set of points made up of and then edges between them. So it's basically a bunch of nodes and edges. It's a triangle mesh. Each one of these is a triangle. Now your graphics subsystem is very good at drawing these very quickly, and it's a very small blob, so my machine has no problem rendering these. But imagine you had millions upon millions of triangles, it would eventually get very slow. So typically people do some kind of post-processing. One second, I've forgotten where the remeshing thing is. Ah yes, so here is a plugin. If I take this triangle mesh and I say let's reduce it down to 20% of its size, I press remesh and I get another mesh. So if you look here on the left, I've got block sinuses and block sinuses. Oh, I clicked on 19%. So one of them is the full resolution, this red one, and the next one in white is got much fewer triangles. So the kind of things that we'll be doing when you're doing surface-based registration is firstly taking some imaging data, secondly outlining it or painting the pixels in some way, thirdly converting it to a triangle mesh, and that would use something called the marching cubes algorithm. Fourthly, a combination of decimation, as it's called. So decimation refers to reducing the number of triangles, and fifthly, smoothing. So you often want to get rid of rough edges, but in one sense that is purely for aesthetic purposes. This would give you a surface which you then give to your program, and the graphics system will just happily render these as a bunch of triangles in a certain color, and it will do it very quickly. And that's, in a nutshell, the process, the overall process of doing a surface-based, so a segmentation, converting it to a surface so that we can do surface-based visualization.